Okay, let me go over the exercises that you have to do from the plots and explain them. Make sure you do the examples. Examples are really important to give you a very good practice, and also discuss a lot of good things like this problem. It will tell you how to take care of when the angle is given half radians and half in degrees, what to do then. And you will see this very commonly in electrical engineering. So go over these exercises, examples, and do those examples. You will learn a lot. Okay, so we discuss multiple plots. Again, the examples to show you multiple plots. You will see everything over here that I discussed in videos. Exercise 10, I'm assuming, is the first exercise that you have to do. And pretty straightforward exercise. You have two functions, f1x and f2x. And I'm asking you to ask user to enter the vector x, like we did in the video. We enter the time value. And then you will have to plot these two functions in two different windows, and sample output is given here. So in this one, my x was 0 and my interval was pi by 100, and I'm plotting it up to 5 pi. Now the graph is going to look something like this. So make sure you plot them in separate windows, put the x label, y label, and put equations as the title of your graphs, and read this, how to introduce Greek letters in your title or in your x label, y label. Okay, make sure you do example 10. It shows you how to do legend and all those things. Exercise 11, let's see what does this exercise say. So you have to plot this function. This is a second the output of a second order control system for a DC input, a constant input. Okay, now here there's something that is different, and that there are two things that are changing. You have this zeta variable, which is called damping ratio, and it has, in this exercise, I'm asking you to use 5 different values of zeta. And of course you have the value of x, which is the x-axis value. Now make sure, keep in mind, this x is outside the square root. I have seen a student making a mistake and taking this x inside the square root, but this is outside the square root. So you have a x over here, and then you have a x here in the exponential power. So you're going to plot these plots. So you have to plot 5 plots when you take different values of zeta, and the x-axis will be same, that you're going to ask user to enter the range of x. So again, these are the 5 plots, a sample output. I'm going from, I think I'm taking pretty much the same range as I showed you in the last exercise, 0 to 14, which is I think up to 5 pi or something like that. And then I have legend of all those. So how you're going to do that? Very simple. In this exercise specifically, just create 5 different vectors, one for each value of zeta. So y1 is going to be this equation for zeta 1, 0.1, y2 will be for 0.2, and so on and so forth. And then you're going to go ahead and plot each of those vectors in the same plot equation, because you're plotting all of them in the same plot. You're going to plot each of them in the same plot for the same value of x. So you're going to do x comma y1, x comma y2, x comma y3, x comma y4, and x comma y5, and it's going to plot 5 different plots for these values of zeta, and use a legend to show which plot correspond to what value of zeta, as we discussed in the videos and in this tutorial. Okay, and then the final thing is subplots. Again, we discussed subplot in the video as well. Go over the example, and then the exercise is that the last exercise that you did, basically now use subplots, choose 3 values of zeta, 0.3, 0.5, 0.8, and plot those in 3 windows in subplot, and then plot all 3 of them in the last window. Okay, so this is the exercise. So zeta is equal to 0.3, plot in the first subplot, 0.5 second, 0.8 third, and then all 3 subplots is going to be in the last subplots, or all 3 plots are going to be in the last subplot. So that's what exercise 12 is, which is the last exercise of the homework. 3D plots, I just put it as for the information purpose. Do it, you're gonna enjoy it to see how the 3D plots look like. These are 3D plots, and then you also have the mesh 3D plots, the surface plots. So if you have time, just play with it. It's pretty beneficial, it looks pretty good. but this is not part of any exercises or any exam problem that I'm going to assign you.